On August 15, 1977, a radio telescope in Ohio detected something that shouldn't exist. A signal so powerful and so precise that the astronomer who spotted it wrote one word in the margin: wow. Nearly 50 years later, the mystery still stands. Tonight, we are diving straight into the most legendary blip in the history of listening to the cosmos. The WOW signal. The Big Ear radio telescope at Ohio State University was quietly scanning the sky for SETI, the search for extraterrestrial intelligence. Days later, volunteer researcher Dr. Jerry Ehman reviewed the computer printouts and froze. There it was at 1420 megahertz, right on the hydrogen line, the universal frequency scientists thought a smart civilization might choose. It was 30 times stronger than the background noise, and it lasted 72 seconds, exactly as long as Big Ear could track a point in the sky before Earth's rotation moved it away. Ehman circled the data in red ink and wrote "Wow." The name stuck, and the legend was born. What made this signal extraordinary was not just the power. It was narrowband, locked to a razor-thin frequency instead of smeared across the spectrum like most natural sources. It showed a subtle frequency drift exactly like you would expect from something far away as Earth rotated under the beam. And when astronomers triangulated the sky position, it seemed to come from the constellation Sagittarius, near the Chi Sagittarii group. Then, just as suddenly as it appeared, it was gone. It never repeated, despite countless follow-up searches. That one-and-done nature is exactly what turns a mystery into a maddening puzzle. Was it an alien ping, a natural fluke, or something embarrassing from our own backyard masquerading as a cosmic hello? Let's test the theories. First, the obvious one: extraterrestrial intelligence. The hydrogen line is a logical calling card. But if it was a beacon, why only once, and why no repeat in decades of targeted observations? Next, an exotic natural source brightened by interstellar plasma acting like a lens. That could amplify a normal signal, but the narrowband precision and the exact frequency choice are tough to square with a random natural outburst. Third, Earth-based interference. Maybe a satellite, an aircraft, or a ground transmission bounced at just the right angle. The catch is the wow. Signal behaved exactly like it was from space, not from our own equipment. Then came the comet idea. In 2017, astronomer Antonio Paris suggested that hydrogen clouds from two comets in that patch of sky might explain the detection. But follow-up analyses found the comets were not emitting at the right frequency, and the signal was too concentrated for that explanation to hold. Here is the halfway point question for you. If you had to pick one explanation today, which theory do you find most convincing and why? Drop your best argument in the comments and tell us what evidence would change your mind. The uncomfortable truth is that we might never know. The Big Ear telescope that heard the signal was demolished in 1997, taking its exact observing setup with it. Modern arrays and even more sensitive dishes have scanned the same coordinates over and over with nothing to show. If it was an artificial transmission, we may have caught it once and missed the rest. If it was a natural event, it might have been a cosmic fluke that will not repeat in our lifetimes. What we can say is clear. The wow signal was narrowband, strong, lasted 72 seconds, lined up with the hydrogen line, drifted the way a distant source should, and came from the direction of Sagittarius. It has never been seen again. That checklist is why it remains the gold standard of unsolved signals. Before we wrap up, if you love mysteries grounded in real data and want more deep dives into the strangest things the universe throws at our antennas, hit subscribe and join us for the next investigation. The wow signal sits at the intersection of hope and humility. It is the perfect reminder that the universe is loud in radio, that our tools can catch remarkable things, and that science advances by chasing the signal and ruling out the noise. Maybe it was a cosmic lighthouse we glimpsed once. Maybe it was an earthly echo we did not yet know how to filter. Either way, it taught us how to listen better. The question that lingers is simple and electrifying. If a 72-second transmission could shake science for decades, what happens when the next one does not hang up?